let's come back. Okay, so we will start doing workshop. Okay, right now พี่ไมค์คะ
ค่ะอาจารย์
เดี๋ยวไมค์ช่วยโชว์น้องหน่อยนะคะ
ได้ค่ะอาจารย์
Okay, so everyone, please open the file. Okay, and in this case, we have the data here. When we enter the data into Minitab, okay, it requires the columns like this. So the column which is the part number, actually different values. Like in this case, we have 10, okay, 15, okay, up to 55, right? Actually, this number is exactly as on PowerPoint, okay, but I will show you how do we do it by Minitab, okay? And then we have to have another column, which is the measurements or the data that come from the measurements. Okay, so we have the data like this. Okay, and the question is, okay, the first question will be, is linearity significant? Okay, and is the amount of linearity acceptable? At which reference values are bias significant, and at which values that bias are unacceptable. Okay, we have done this before. Okay, and then we will do this. Okay, sorry, I have to share the screen, right? Not sure. Do you? Okay, now you can see the Excel file, right? Okay, sorry about that. Okay, so you have to enter the reference values column and the measurements columns. Okay, you can copy. Okay, there's two columns. Okay, onto Minitab. Okay, and okay, and then okay, the question will be for question here is linearity significant? If yes, is the amount of linearity is acceptable? Okay. And the third question is, at what reference values are bias significant? And the last question is that at which values that the bias are unacceptable. Okay. And then you can put your answer onto this Excel file. Okay, and why here? You can write down the numbers that you consider to make this conclusion. Okay, and take a look at this. Okay, when you have to calculate the percentage of bias over process variation, so you have to have the numbers. Okay, so 6 sigma here. Okay, suppose we have done previous analysis. Okay, at each reference values. Okay, it has the 6 sigma roughly about 5.1. Okay, so what you need to do is that for reference value of 10, okay, you do process capability analysis, right? And then you get the sigma with a number. Okay, you multiply by 6, you may get, for example, 5. Okay, and for 15, you get another number. Okay, and then you can average those numbers based on the formula for average sigma. Remember that there's a formula about sigma pool. Okay, we have seen that formula before. Okay, you can revisit the process capability content. Okay, and then you get the average. Okay, sigma value. Okay, and then you multiply by 6, you will get this number 5.168, and then we will have to plug in this number into Minitab. Okay, to calculate the percentage of bias. Okay, ค่ะ now พี่ไมค์ค่ะ could you please show
ค่ะอาจารย์ค่ะแล้วก็กรอบ Data นะคะ เอาไปลง Minitab โอเคก็จะเป็นแบบนี้กรอบกันแล้วใช่ไหม ต่อไปที่ stat นะคะ แล้วก็ไปที่ quality tool แล้วก็ไปที่ gate study แล้วก็เลือก gate linearity and bias study ค่ะ
ขอโทษนะครับตามไม่ทันครับเพราะว่ายังไม่เห็นหน้าจอครับ
อ้าวไม่เห็นหรออันนี้เห็นไหมเอ่ยแป๊บหนึ่งนะมันไม่ขึ้นอันนี้เห็นยังคะ
เห็นแล้วครับ
โอเคค่ะcopy data เนาะจาก Excel ไป Minitab แบบนี้โอเคค่ะถ้าก๊อปเสร็จแล้วให้ไปที่ stat แล้วก็ไปที่ quality tool นะคะแล้วก็ไปที่ gate study แล้วก็เลือก gate linearity and bias study ค่ะอาจารย์ค่ะอาจารย์ไม่ค่ะไม่ค่ะค่ะค่ะค่ะอาจารย์เข้ามาใน QCM แล้วใช่ไหมคะใช่ค่ะเดี๋ยวหนูกดเชิญอาจารย์เข้ามาก็ได้ค่ะเดี๋ยวแป๊บนึงนะคะค่ะเชิญอาจารย์ไปแล้วค่ะขึ้นไหมค่ะโอเคค่ะ
โอเค
ค่ะทุก
ขอ
ค
โท
น
ษทีทุกคนของอาจารย์มันหลุดไปโอเคเพิ่งเข้ามาพี่ไมค์โชว์ต่อนะคะ
ค่ะทุกคนทันแล้วใช่ไหมคะตรงนี้ก็กดเข้าไปเลยค่ะ linearity แล้วก็ใส่ช่องแรกจะเป็น part number นะคะให้ใส่นี่คอลัมน์ C1 ก็คือ part number แล้วก็ reference value ก็คือใส่อันนี้เลยค่ะแล้วก็ measurement data ก็ใส่คอลัมน์ measurement แล้วก็ใส่ค่า sigma นะคะก็คือในที่นี้จะเท่ากับ 5.168
ค่ะตรงนี้เป็น6ซิกมานะคะต้องอย่าลืมเอาไปคูณ6ก่อนข้างล่างเห็นไหมมันเขียนว่า6คูณซิกมาค่ะ
ค่ะจากนั้นก็กดโอเคค่ะทุกคนทันไหมเอ่ย
ไม่ลองกดตรง gauge info กับ options หน่อยสิคะ
ได้ค่ะไม่มีอะไรค่ะจ้ะ
gauge info okay you can tell the name okay the date of study okay so you don't have to
option
method for estimating repeatability standard deviation okay you can use sample range or sample standard deviation okay either one is fine okay in the default is called use sample range but actually it's better if you use sample standard deviation
ค่ะจากนั้นก็กดโอเคค่ะก็จะได้เป็นแบบนี้
okay okay when we obtain this output okay you can copy it okay by right click okay right click and then พี่ไมค์ลองทำนะคะ and then copy graph and paste it onto Excel file okay to hand in the result Okay, and okay, everybody, please fill in the answer. Okay, and then you have to hand in this output. Okay, as one part of the homework. Okay, so please do this one more time very quickly. Okay, so พี่ไมค์คะช่วยสุ่มถามน้องสักคนหนึ่งค่ะ First question is linearity significant? Okay, so answer in the answer column, you will say significant or not, and why. Okay, in the why column, you should tell the numbers that you consider or you compare. Okay. Okay, first question พี่ไมค์ถามใครดีคะใครยังไม่ถูกถามไปบ้างวันนี้
ดูก่อนนะคะไม่รู้เหมือนกันจำไม่ได้
เดี๋ยวหลังติ๊กไว้อ่ะ
อิสรี
อาจารย์ดูอิสรียังไม่คุยกันจำได้
ค่ะ
อิสรีคะ
ค่ะ
โอเคพี่ไมค์เปิด Excel หน่อยค่ะ Okay, the first question is linearity significance. So what do you say?
แป๊บนึงนะคะพอดีว่าเหมือนเน็ตไม่ค่อยดีหน้าจอก็เลยเบลอนิดหน่อยอะ
โอเคงั้นอีกที fix problem กันนะเดี๋ยวจะกลับมาถามใหม่โอเคต่อไปนันนภัทรค่ะนันนภัทรก็ยังไม่ตอบใช่ไหมนี้โอเค first question นันนภัทรค่ะ
อาจารย์คะหนูยังไม่ได้กราฟออกมาเลยนะคะ
เหรอคะโอเคตามทันไหมต้องการให้
รีแคปอีกรอบได้ไหมคะ
โอเคได้ค่ะพี่มายช่วยโชว์น้องอีกรอบนะคะ
ได้ค่ะcopy data มาแล้วใช่ไหมจากนั้นไปที่ stat ค่ะไปที่ quality tool ไปที่ gate study แล้วก็ไปที่ gate linearity and bias study ค่ะ
โอเคค้างไว้ก่อนค้างไว้แป๊บหนึ่งก่อนให้น้องนันนภัทรถึงตรงนี้ได้แล้วบอกพี่นะคะ
ได้แล้วค่ะอาจารย์
โอเค
กดเข้าไปเลยค่ะแล้วก็part number ก็ใส่เป็น column C1 นะคะที่เขียนว่า part no แล้วก็ reference value ก็ใส่ column C2 ที่เขียนว่า reference value นะคะ measurement data ก็ใส่ column C3 measurement
Okay. So when we do this analysis, so we have to prepare the data in the format that Minitab requires. Okay, so Minitab requires 3 columns. The part number column, okay, C1, right? In C2 column, so we have to prepare reference values. Okay, we have to enter reference value first, and then the measurements columns. Okay, so you have to prepare those 3 columns in advance, right? Before you click onto this analysis. Okay, and the last thing, it asks for process variation. Okay, so you have to do process capability analysis first. Okay, and then you will get 6 sigma. Okay, from the parts. Okay, and then you plug in 5.168. Okay, and then you can click on okay, and then you will get that graph. Okay, when you click OK, you will get the graph. Okay, Nanapat, have you got the graph yet?
ค่ะอาจารย์
Yeah, and then you right click, okay, and then copy the graph and paste it onto Excel. Yeah, no?
ได้แล้วค่ะ
Okay. Okay. ได้แล้วค่ะงั้นจ้าได้แล้วนะงั้นนันนภัทรค่ะ could you please answer the first question?
percent linearity ใช่ไหมคะอาจารย์
Is linearity statistically significant? เสียงมันก้องเลยโอเคแล้วค่ะ
Okay, so since the percent linearity is equal to 1.1, so it's significant because it's like less than 5%.
Okay. So the numbers that you're talking about, you will use them to answer the second question. Is the amount of linearity acceptable? Okay. So you will take a look at the percent linearity, okay, number. Okay. So that's right. You can answer the second question. But now we are talking about the first question. Is linearity significant? So to judge whether linearity is significant, we will not take a look at the percent linearity, but we will take a look at which number. Isari, can you come back?
yes ค่ะ
Okay, Isari, could you please help answer the first question?
So since the R square is greater than 80%, so it's a linearity pattern ค่ะ
Okay, but yeah, R square can be used. Okay, that you should take a look at the R square number also, but it's not the numbers that you would use to judge whether the linearity is significant. Okay, so can anybody tell me which number or which indicators that is used, okay, directly to decide whether linearity is significant? Can anybody tell me? Uh, ไม่มีใครตอบเลยหรือ เดี๋ยวจันเรียกนะพี่ใหม่งั้นเชิญน้องตอนนี้พูดถึง R square is not a direct indicator. Okay, so which is the direct indicator to judge just for significance? พี่ใหม่เดี๋ยวจันดูเองก็ได้ค่ะเดี๋ยวจันอิสรีไปแล้วกฤษไปแล้วนันนภาจะก็ไปแล้วเนี่ยนภกรไปยัง
ไปแล้วครับ
นรพัฒน์ตอบไปยังวันนี้นรพัฒน์ค่ะต่อเวลาพาริสนี่ไปแล้วภวัตยังมั้งใช่ป่ะ
ยังครับ
ภวัตคะ
ครับ
อยู่ไหม
อยู่ครับอาจารย์
งั้นภวัตช่วยข้อนี้แล้วกัน
is that the p value
Yes, good. P value of which term?
The constant and the slope.
Okay, yeah. But you can take a look at the p-value of the slope, okay? Because the slope tells you whether there is a linear relationship or not, right? Okay, so you can take a look at only one number, which is the p-value of the slope. Okay, and then what do you think is the p-value?
Well, it's less than 0.0005.
Yes, very good. Okay, and then what's next? Okay, to make conclusion, so you have to compare this p-value with which number?
Which the alpha.
Okay, you can say okay for whole sentence until you reach your conclusion.
ครับ So since the p-value of the slope is less than the 0.0005, which is the value of the alpha, so we can conclude that the linear.
I'm sorry, I'm not sure that I follow you exactly. Okay, you said that the p-value is less than 0.0005, right? That is correct. And then what's next?
So like since it is the alpha
No,
value.
this number is not alpha, right? This number is not alpha. What is the value of alpha that we usually use?
5%. So it's
5%.
0.05.
0.05. Okay,
Ah.
right? So p-value is less than 0.005 and alpha is exactly at 0.05. Okay, so how do you link these two numbers?
So the p-value is less than 0.05, which is the alpha number.
Oh, okay, right,
Yep.
right. Yeah, very good. And then your conclusion is?
So my conclusion is that so we can accept the linearity.
Okay, yes, you can say that linearity relationship between bias and reference value is significant. Okay.
Yep.
Okay, that's good. Okay, come back to what Isuri said, right? Isuri talked about the R square value, right? In this case, what is the R square value again? มันโชว์อยู่ตรงไหนนะคะไม่อาจารย์มองไม่ค่อยเห็นขยายนิดนึงได้ป่ะขยาย Excel ให้หน่อยค่ะR square okay, everybody, do you see R square number? Okay, R dash square 81.1%. Okay, so you can say it like this. Okay, when you compare the p-value with alpha, right, and then you conclude that the linearity pattern is significant. Okay, next you can say that this pattern, okay, or this fitted line, okay, can explain. Okay, now you will talk about R square. Okay, so you will say that R square means that it means the percentage of the variation, okay, of the data that can be explained by the fitted line. Okay, if it's 100%, that means this fitted line can explain the actual data point perfectly. Okay, it will follow all data points. Okay, but if it in this case is 81.1, so you will say that this significant fitted line can explain the overall variation of the data of 81.1%. Okay, it can explain overall data point by 81.1%. Okay, which is pretty good because the acceptable R square value is greater than 80%. In this case, it's 81. Okay, it's greater than 80%. So we can say that it can explain the data pretty well. Okay,
อาจารย์
will we ค่ะ
เมื่อกี้ value ที่เป็น 0.0005 อะมาจากไหนครับ
Okay, the p value of slope, do you see that is equal to 0.000, right?
ครับ
Okay, and this number actually is not exactly at 0. Because Minitab report only 3 digits, okay, 3 decimal places. So that means the fourth digit, okay, should be less than 5. Okay, so when it reports only 3 digits, it will round down the number to 0.000. Do you get that?
ครับ
That's why I can refer, okay, or I can predict that the fourth digit should be less than, okay, 5. So I will say that p value is less than 0.0005 because in theory p value cannot be exactly at 0 because it has to have some probability, but it's very small in this case. Do you get that?
ครับ
Okay,
โอเค
ค่ะgood. Okay, and the next question again. Okay, question number 2 again. Actually, we have talked about that. But maybe Sirovit, could you please answer the second question again to make sure that everybody understand this? Okay, the second question. The question is that, okay, from question 1, right? Now we know that the linearity pattern is significant. So the next question will be this pattern, okay, this amount of linearity, is it acceptable? Okay, so which indicator that we should take a look to answer this question? okay เพื่อนเราได้ช่วยตอบไปแล้วแหละ but I would like to make sure okay for the second time that everybody capture this okay ค่ะศิลวิทย์ช่วยตอบหน่อยค่ะ the second question
ตัวนี้มันต้องดูเปอร์เซ็นต์ก่อนครับใช่ไหม
ค่ะถูกค่ะต้อง take a look at percent which percent พี่มายช่วยโชว์ data data หน่อยค่ะโอเคค่ะเปอร์เซ็นต์ตรงไหนคะศิลวิทย์
เปอร์เซ็นต์ bias หรือเปล่าครับ
ยังไม่ใช่ค่ะยังไม่ใช่ now we are talking about amount of linearity okay linearity means slope okay so okay which number
1.1
yes good that number 1.1 is called percent linearity okay good and then what's next okay in the final exam I will ask you things like this is amount of linearity no is amount of linearity acceptable yes or no okay and to answer that question which numbers okay should be more than two numbers okay which numbers number than two number maybe two numbers that you have to take a look to reach that conclusion okay so Silavit could you please do the whole sentence by yourself
แป๊บนึงนะครับ
ค่ะ
คือให้ตอบว่าเป็น acceptable or unacceptable ใช่ไหม
yeah accept or not okay so you take a look at the percent linearity of 1.1 right but you have to compare it with the criteria of acceptance right so you have to tell me the criteria and then you have to compare okay
because the percent linearity is less than 5% I guess so it is unacceptable I'm not sure
okay good but do not miss one thing you have to be clear that percent linearity of 1.1 you should mention that okay to be clear okay
is the answer right
yeah it's right but you just have to tell percent linearity of 1.1 okay is less than acceptance criteria of 5% okay you have to tell the numbers also okay good okay the third question พี่ไมค์ขึ้นไปข้างบนเลยค่ะ at which reference values are biased significant okay ฝักลงมาข้างล่างค่ะโอเคคราวนี้อาจารย์ถามสุภวิทย์could you help answer this question okay and tell the numbers that you are considering
ครับอาจารย์
ค่ะ
ข้อ3ใช่ไหมครับ
yes
10 15 20 and 25
significant okay
yes
สงสัยจำสลับ significant so also which indicators are you looking at
the p value
yes okay you should take a look at the p-value exactly okay and then you have to compare it with which value
alpha
right okay and then okay you say so p-values are greater than alpha right
yes
for reference value of 10 to 25 okay that's correct but what is wrong is that you remember it wrongly okay when the p-value is greater than alpha you should conclude that not significant Okay.
Okay.
So it's significant when p-value is less than alpha. Okay, so everybody, you should be able to remember right now. Okay, so that you don't have to review it again for the exam. Okay. Now, if you remember switch, so you have to remember it right now that p-value less than alpha means significance. Okay, for all the cases when you do hypothesis testing, any hypothesis test, okay, p-value less than alpha means significance. P-value greater than alpha means not significant. Okay,
Okay.
so one more time, Supavit, at which reference values that bias are significant?
30, 35, and 40.
Okay, great. And in this case, actually, if you take a look at the graph, we have the data, we have the different values of 45, 50, and 55 also. Okay, but Minitab doesn't report those numbers because it has limited space. Okay, so in this case, if you know that the reference values are up to 55, so you can say that, you can guess that they are significant for reference value of 30 to 55. Okay. Because the bias is increasing, as your friend told us one more time, right? The bias is increasing from 30 to 55. So we can expect that when the part is 45, 50, and 55, the bias should be a lot, it should be large, and then there should be significant also. Okay. Okay, the last question. At which reference values, okay, are biases unacceptable? Okay, so we have to take a look at the data output again. Okay, and now, okay, which indicator that you should take a look at? Okay, สุพิชาแล้วกันนะคะ
percent bias ค่ะ
ค่ะ อาจารย์ขอเสียงดังนิดนึงค่ะ
แป๊บนึงนะคะอาจารย์พอดีที่บ้านฝนตกอาจจะ
อ๋อ
ไม่ค่อย
แล้วโอเคงั้นก็พูดดังๆเลยแล้วกัน
ค่ะlook at percent bias ค่ะ
ค่ะ
so at 40 the biases are unacceptable ค่ะ because it's greater than 5%.
Actually is at 5%, right?
ค่ะ
And the criteria is that when it's greater than or equal to 5%, okay, greater than or equal also unacceptable, right? But accept when it's less than 5%. In this case, it's exactly at 5%. Okay, so unacceptable at 40, right? Okay, good. And how about 45 to 55?
They are unacceptable as well ค่ะ เพราะว่าif you see the graph the bias is more than at reference average of 40 which is more than 5% ค่ะ
Okay, very good. Okay, you see the increasing trend after that, so you are pretty sure that not pretty sure, you're exactly sure that the percent bias will be greater than 5% when the part are greater than 40, right? Okay, that's good. So the answer will be 40 to 55. Okay, great. Okay, so from this workshop, okay, I hope that, okay, everybody will clearly understand, okay, which indicators that we consider when we answer each question. Okay, so please summarize it as a group. Okay, so make sure that your group, okay, can answer this correctly. Okay, and then you can hand in, okay, one person hand in the results, okay, in the link that Pima will create for lab number 4, okay, bias and linearity. Okay, so I think we will be done for the workshop about the accuracy. Okay, so for accuracy, to summarize for 1 minute, okay, in terms of the accuracy, we have seen the analysis. Okay. Just a second. Okay, I'll come back to the slide. Okay, let me share the screen. Okay, come back to this slide. Okay. So now we have learned about accuracy appraisal. Okay, and then we take a look at the details of how do we appraise about linearity and bias for each reference values. Okay, we can do this two analysis at the same time. Okay, using Minitab. Okay, and for stability, we have to do it separately. Okay, using control charts. Okay. And in the next class, okay, we will talk about precision appraisal, okay, which the tool is called gauge R&R, okay. Repeatability and reproducibility, that is what we are appraising for the precision of the measurement system, okay. And we will have like 35 minutes left. Okay, so I would take some time, okay, to talk about the final exam, okay, and if we have some remaining time, so I will talk about the precision appraisal a little bit, okay. Okay, first, let me ask you first, do you have like any question or the points that you want me to talk about the exam? If you don't have any idea, so maybe I'll guide you. Okay, so for the final exam, okay, the contents that will be covered is, first we talked about control charts, right? Okay, next we talk about process, okay, capability analysis. Okay, I just call it in short as PCA. And next we talk about attribute agreement analysis, right? From last time when we have the result from the inspection. Okay, and today we talk about MSA for variable data. Okay. This content AAA we will not cover in the exam. Okay. I appraised you by the homework. Okay, that is enough. Okay, because it's pretty easy, so I will not talk about it anymore. Okay, so we will have control charts, PCA, and MSA. Okay, in the exam. Okay, and now I will talk about the expectation for each content. So for control charts, okay, first you have to be able, okay, to select proper types of control chart. Remember that we have variable control charts and attribute on control charts, right? Variable, we have X bar with R charts. We have X bar S and XMR, right? XMR, we can call it as IMR. X and I are the same thing. Okay. Okay, you have to be able to distinguish between these three types of charts. Okay, so the first two, okay, actually use when in one sample, okay, we can collect more than one part. Okay, so if we have more than one part, okay, we will take an average X bar, right, to explain about the mean of the process, right? And then we will use R range or standard deviation to explain about the variation within, okay, sample or within subgroups, okay. And then we plot on the chart to see the change or the shift, right, of the mean or the variation over time. Okay, and now you should be able to tell, okay, at which situation that you should use R chart, at which situation that you require to use S. Okay, and we've talked about this in the slide that when you have, or in the situation that in one sample or one subgroup, you can collect sample size or the number of parts greater than 10, okay? So in that case, okay, using R range is not a good statistics, okay? Because it's used only two numbers, maximum and minimum, okay? So you neglect 8 data points, okay? So that are too many. So you have to use S charts only in that case, okay? But when you have like any n, okay, when you have small n or n is less than 10 or n is 10, sorry, n is less than 10 or n is greater than 10, okay, you use S standard deviation is good, okay, because S use all the data points that we have, right? So generally using S is better than using R, okay? Right now we use computer software, okay? So calculating S or R is equal in terms of the difficulty, okay, for the calculation. But in the previously, like many years ago, okay, when computer is not very common, okay, so they have to calculate calculate it manually, okay. So calculate R is much easier than calculating S, okay. So that's why in the past people use R charts instead of S, okay. But in like now today, using S is better in terms of the quality of the information that we will obtain, and also the calculation is not that difficult anymore, okay. So I recommend you that if you have to pick up or use R or S, you can use S, okay, in any case. Okay, so we finish, okay, for X, Y, and S. And XMR, okay, we use when we have sample size of 1, okay? That means for each sample, okay, if it makes sense to collect only one data point. For example, if you produce the chemicals, okay, in a batch, okay, and then you want to monitor the variation of, for example, viscosity over batch number 1, okay, number 2, number 3, you want to see the variation, okay. So in each batch, okay, the viscosity is, there's only one number for viscosity in one batch, right? So it doesn't require you to take sample of more than one time, okay? So you can take sample only one time, okay, per batch. Batch here in this case is the subgroup, okay? So in chemical process, okay, so we will use XMR or IMR, okay, as the control chart. Okay. Next, okay, come to the attribute control charts. We have learned 4 types of charts, which is NP. So NP monitor the number of rejected part or number of defective, we can say that. Okay, and then if we convert the number of defective, okay, divided by the number of parts that we sample or the sample size, we will get what we call proportion, right, of defective. Okay. So actually NP and P, okay, represent the same thing. It represents how many parts that we produce as defective, right? But P we represent as the proportion, and P we represent it as the number of parts that are defective. Okay. So for example, and to distinguish between these two types of charts, we have to consider the sample size. The sample size means the number of parts that we collect in each sample. If sample size is constant mean for each subgroup, for example, if you have subgroup like 1, 2, 3, 4, 5, if n, or the number of parts that we sample, is for subgroup number 1 mean from hour 1. If we collect 100 parts, hour 2, 100. In each hour, we collect the same number of parts, which is 100. That means n is constant, okay, over subgroups, right? In that case, okay, is when n is are equal, okay, for all subgroups, it's fair, okay, to monitor the number of defective, okay, over subgroups, right? Because it comes from the same ground, which is the same number of parts, okay? But when n is not constant, we cannot use NP, right? Okay, because the number of defective come from different numbers of parts. So it's not fair to compare between subgroups, right? Okay, so if sample size is not constant, you have to use P chart, which shows the proportion. So proportion will compare the number of defective over n, okay, which can be, okay, not constant, okay. But if n is constant, do you think we can use P chart? Isarika, if n is constant, do you think we can still use P chart?
if n is constant ใช่ไหมคะ
ใช่ค่ะ
no.
Why? Suppose in this case n is constant, right? If we have defective like 10, 6, 8, 7, 5, when we use P charts, that means, okay, we'll calculate D over N, right? The proportion of defective. So this will be 0.1, 0.2, 0.06, 0.08, okay? And do you think it's okay that we plot the P chart when we have the case of equal sample size?
Yes ค่ะ
Yes, okay, it makes sense also, right? Okay, so P charts can be used in any cases, okay, when we have n constant or when n is not constant, we can still use P charts, okay? But NP, okay, it's used only when we have n constant. But when n is not constant, do you think that NP is suitable or not when n is not constant?
no หรือเปล่าคะ
Right, no. Take a look at this. If you have 5 subgroups, right? When n is not constant mean, okay, subgroup number 1, we have 100 parts. Second group, you may have 80, okay, it's not constant. Okay, and then if you collect the number of defective, okay, D is, we can call it as NP, okay, the number of defective. If it 8, for example, 7, 9, 7, 6, okay. If you plot NP charts, that means you plot 8, 7, 9, 7, 6, things like that. So do you think it's fair, okay, to compare the number of defective over subgroups when you have different numbers of parts? Isari, do you follow me?
Can you repeat it again?
Okay. When you have the situation that n are different over subgroups, okay, do you see that? N change over subgroups, right? Or we can say that n is not constant, okay? N is not constant over subgroups, okay? And if we, okay, collect the data, for example, from 100 parts, we have 8 parts that are defective, okay? And then we have the numbers for each subgroup, like for example, 7 out of 80, 9 out of 90, okay? And do you think, is it fair, okay, that we plot, okay, or compare, okay, the numbers of defective over subgroups like this? If we plot only NP, which is the number of defective, okay, and you say that this, okay, number of defective is pretty high, for example, it's pretty high, but this number comes from 100 parts, okay, this one 7, okay, is less than 8, right? But it comes from only 80 parts. So do you think it's fair to say that the number of defective, okay, or the defective rate, okay, of the second subgroup is less than the first subgroup when you just compare the number of defective, but do not consider the number of sample size A at all?
I think it's not fair.
Right, it's not fair, right? So if it's not fair, that means when you have non-constant sample size, you shouldn't plot NP chart, right? But what do you need to do? What do you need to plot? Okay, anybody can tell me? Ah, ไหนเราลองเปลี่ยนไปคนอื่นบ้างนะ นภกร okay, so which type of control charts or which indicator that we should use, okay, or should calculate, okay, and plot instead of use the number of defective?
defect ป่ะครับ
Defect. No. Oh, one thing when you talk about defect. Okay, remember this. There's one slide that tells you about the difference between the wording defect and defective. Okay, they are different. Okay, so a defective means a part that contains at least one defect. For example, this part has one scratch, so there's one defect, and this part is a defective. Okay, this part contains 2 defects. Okay, and defective means a part that contains at least one defect, right? So this part is called a defective. Okay, and this part contains no defects, right? 0 defects. And we can say that this part is not a defective. Okay, so out of 3 parts that we have, okay, we have in total 1 plus 2 plus 0. We have 3 defects, okay, over 3 parts, okay, and we have 2 defective, right? This one and this one. We have 2 defectives. 2 defectives over 3 parts. Okay. Remember process capability analysis. We have a measure which is called DPU. DPU is the number of defects over 1 unit. Okay. It's a defect rate. So 3 defects over 3 parts is equal to 1, right? DPU, 1 defect per 1 unit. Okay. And if we take a look at the number of defectives, okay, we can say that the reject rate, or we can say defective rate, is 2 over 3, okay, which is a proportion of defective, which is 0.67. Okay, so now I just want you to distinguish about defect and defective. They are related in the sense that a defective contains at least 1 defect. Okay, but defective, okay, when you take a look at the part which is a defective, okay, you do not care how many defects that occur in that part, but you just consider that if this part contains a defect or not, contain at least 1 defect or not. If it contains defects, so you will say that this part is a bad part, okay, but the part is a good, which is a good part, or a non-defective is a part that contains no defect at all, okay. But if we take a look at the number of defects, that means you want to take a look into details, that how many defects that happen in each part, okay. For example, in the second situation, you have the same defective rate, 2 out of 3. But, okay, in this case, you have 2 here, and you have 1, 2, 3, 4, okay? In this case, okay, in the second case, the number of defective, okay, defective rate is still the same, right? Which is 2 parts out of 3 parts, okay? But DPU, defect rate is 2 plus 4 over 3 parts, right? Which is 6 over 3. And then, okay, in the second situation, you have on average 2 defects over 1 unit. Okay, so your DPU will be 2. But in the first case, you have lower defect rate, which is 1 DPU. Okay, so in the 2 situations, you have the same defective rate, but different defect rates. Okay, so defects and defective are not the same thing. Okay, so you have to be careful when you talk about defect and defective. Okay, you have to be very sure that now you consider defect or defective. Okay, so come back to this point. Okay, so for P charts and NP charts, we consider the number of defective. Okay, so we do not consider how many defects that happen within each part. Okay, we do not care. We just care for the number of parts that are defective. Okay, so if we have non-constant n, like in this case, okay, so what we have to do is to convert the number of defective, okay, into the defective rate, which is called P. Okay, so we have to take this column, okay, and then divide it by the column of n, okay, and then we will get 8 over 100, right, which is 0.08. And 7 over 80, okay, you can calculate it. This is 9 over 90.1. 7 over 100. 6 over 85. Okay, so now, okay, P means the number of defectives over 1 unit that we sample, right? So now it's fair to compare among the subgroups because we have the same base, which is 1 unit, okay? But when we take a look at D column, it's not from the same base because the sample size are different, okay? So that's why when we have non-constant sample size, we have to convert the number of defective into the P value, the proportion indicator, and now it's fair to plot, okay, the proportion over time. Okay, so the charts that we will use in the case of non-constant sample size is P chart, okay? But as I mentioned before, when you have the case of constant sample size, you can still use P chart, okay? So to summarize about this, for any n, for P charts, you can use for any n, okay? But NP charts should be used only the case that you have you have constant sample size. Okay, does it make sense? Okay. Do you have any question to this point? Okay, if no, okay, we will move to the last two types of charts, which is C and U. Okay, so C and U. Now we will consider defect rate. Okay, defect rate. So DPU, okay, we can call it as another name, which is just U. Okay, U. So U means number of defects over 1 unit, or we can call this as DPU. Okay, but C, we monitor the number of defects, okay, over n parts. For example, subgroup number 1, 2, 3, 4, 5. If we have n, okay, which constant, for example, and then we count the number of defects over 100 parts, and then if it's 5, 6, 7, 8, 6, 5, for example, okay. When sample size is constant, okay, so you can plot or see, okay, the number of defects over time, okay, because it's fair to compare based on the same number of parts, okay. So C here is the numbers of defect over all sample size, okay. But when you have non-constant sample size like 180, 90, 185, for example, and then you count the number of defectives, okay, like you have 5, you have 7, 8, 6, 5, like in this case, okay. So you can use the same basic that you have with NP and P, right? Okay, so if N is not constant, it's not fair, right, to plot C, to compare C, right? Okay, so it's much better if you calculate the C over N, okay? That means you calculate the number of defects over 1 unit, okay? So now you compare the number of defects on the same ground, which is per 1 unit. Okay, that is called U or DPU. Okay, so this will be 0.05. This will be okay. So okay, 7/80. Okay, so you know that. Okay, you can calculate the U number, and what should you plot as the U number? Okay, when you have non-constant. Yes. Okay, so to summarize, when you have constant sample size case, so you can use C chart, and then you can also use U. Okay, you can compare over 1 unit or 100 units. That's both are fine. Okay, but when n is not constant, you can use only U charts. You shouldn't use C charts, right? Because you have to compare on the same graph. Okay, so to summarize, C chart is used when the case that you have n which is constant only, but U chart you can use in the case of any n. Okay, any n mean n constant or not constant, you can use it. Okay, I hope you follow this. Okay, that is the first point that I need you to know. Okay, about control chart, which is selection of the proper type of control chart. Okay, the next topic that you need to be able to do is to construct. Construct means to calculate the control limits for each chart. Okay, so for X bar chart, you have to be able to calculate the control limits for all the charts type. Okay, so you have the formula already. You should be able to calculate it. And the third topic is to interpret the pattern that you have seen on the control charts. We have 8 rules, remember that? 8 rules. Okay, extreme point, 2 out of 3, 4 out of 5, run trend, those things. Okay, so you should be able to interpret, okay? So if the graph, for example, if you see the trend, okay, trend on X bar charts, okay, you should be able to say that the process mean, the keyword is the mean because it's X bar, right? Is increasing, for example. But if you see the trend on our chart, you have to say that the process, the variation within subgroup, okay, within subgroup variation of the process is decreasing. So you should be able to tell the direction increasing or decreasing, and you should be able to tell the statistics that you are looking at. Okay, X bar tells you about the mean, and S or R tells you about the within subgroup variation. Okay, so that's all for the control chart content. Next, PCA, process capability. We have many indicators, reject rate, okay, or defective rate. It's easy, okay, to calculate, okay, which I showed you before, okay. And this, okay, example, right? You see the reject rate or defective rate. You see DPU, right? DPU mean defect rate. Okay, so you should be able to calculate defect rate also. And defect rate, you have 2 measures. The first one is DPU. The second one is DPMO. So you have to review DPMO by yourself. Okay, And the third one is the yield. And yield, you have many types of yield. So you have what we call first time yield. And if you multiply the first time yield of all processes, you'll get what we call final yield. And then this, we do not concern the number of rework, okay? But if we concern rework, the number of rework, review this by yourself, okay? We will have another two yield, which is what we call throughput yield. Which is the yield of each process, okay, by consider both rework and scrap. And if we looking at the yield of all processes together, we will have what we call roll throughput yield, okay? And then the last type of yield is called normalized yield, okay? It's used when we compare the yield of two production line which have different number of steps, okay? So please review all types of yield and you should be able to calculate it, okay? Calculate all of them, okay? And the fourth thing, okay? So there's three indicators usually used with the attribute data, okay? When the inspection result is like half defective or not, okay? But when you have variable data, we will use what we call process capability index. And we have four, okay, index, CP, CPK, PP, PPK, okay? We have learned about this. So you should be able to interpret based on like the criteria of 1.33, right? And then you should be able to tell that CP is about the variation. CPK is about both variation and the mean. Okay, and then we use this CPK to design whether we're going to accept about the process capability, but CP we will decide about whether we will accept the variation. Okay, CPK to accept the whole, like the capability of the whole, the process. Whole mean in terms of like both variation and the mean at the same time. Okay, and then you should tell the approach for improvement. For improvement, we have three approaches. Okay, to reduce only variation, but do not adjust mean, not necessary to adjust the mean. Okay, the second one, so different. We should adjust the mean to the target, but do not need to reduce variation. And the third approach is that we have to do both. Okay, remember this, we have done the workshop about this. Okay, so this is all for process capability analysis. And okay, for MSA, okay, we have learned today about bias, right, and linearity. So you should be able to do what we have done, okay, as in the workshop, okay? So if you can answer those 4 questions that we do in the workshop, okay, linearity is significant or not, okay? Sick or not, amount of linearity, okay, is acceptable or not, okay? At reference value which are significant, at which reference value is that amount is not acceptable, okay? So if you can answer this 4 questions, okay, that's satisfying or what I expect from you, okay? And next, in the next class, we will talk about another tool, the last tool that we will learn in this class, which is called GHINR. Okay, this is about the precision of the system, and this tool is about the accuracy of the system. Okay, and in the next class, we will have the workshop again. Okay, and there are a list of questions that you should be able to answer. Okay, so we will talk about this in the next class. Okay. So, okay, if you want to start review the content, okay, for the exam, okay, so you can make sure that you can answer all the questions, okay, all the things that I have mentioned in this file. Okay, I will save this file and then I will put it onto course wheel, okay, so that you will have a note of what I expect, okay, from you in the exam. Okay, so I think we are running out of time, so we will do GHINR workshop in the next class, and then you can come, okay, you can prepare all the question that you may have, okay, and then you can ask me in the next class. Okay, พี่ไมค์คะเราโพสต์พวก example of question ให้น้องๆวิชานี้ยังคะ
ยังค่ะอาจารย์
โอเคอาจารย์มี list ของคำถามเนาะเกี่ยวกับเรื่องเหล่านี้ค่ะอาจารย์เคยทำไว้ในวิชาอื่นๆนะแต่ส่วนใหญ่มันจะเป็นภาษาไทยอะค่ะก็มันจะเป็น URL หนึ่งนะถ้าเดี๋ยวอาจารย์จะโพสต์ให้ถ้าเราเข้าไปที่เว็บลิงก์อันนี้ค่ะมันก็จะมีคำถามต่างๆนะของกลุ่มต่างๆที่เขาเคยส่งคำถามมาให้อาจารย์คือตรงอาจารย์พวกเราสามารถไปฝึกนะคะตอบคำถามเหล่านี้ได้มันก็จะเป็นแหล่งที่ดีในการฝึกตอบคำถามเพื่อข้อสอบไฟนอลของเรานะเดี๋ยวอาจารย์จะโพสต์ในคอร์สวิวนะคะ URL นี้เดี๋ยวพี่มาช่วยโพสต์หลังคลาสนี้หน่อยนะคะ
ได้ค่ะ
โอเคค่ะแล้วก็น้องๆก็อาจจะไปฝึกทำแล้วก็ถ้าคราวหน้ามีคำถามอะไรก็มาถามอาจารย์ได้ในคราวหน้านะคะโอเคถึงตรงนี้มีใครมีคำถามอะไรไหมคะโอเคค่ะถ้าไม่มีนะเดี๋ยววันนี้เราก็เท่านี้นะคะแล้วก็เดี๋ยวคราวหน้ามาดูเรื่อง GHINR กันโอเคค่ะสวัสดีค่ะ
ขอบคุณครับ
ค่ะสวัสดีค่ะทุกคน